We're working with cells, and we're working with looking at how the plasma membrane controls what goes in and goes out of cells, or whether what comes into cells and what goes out of cells. And so today we're going to be looking at how things move through that plasma membrane in and out. This is about diffusion, things moving in. Okay? Diffusion is when something is dissolved in water. The solute, what is being dissolved, will scatter until it is evenly spread out in the solvent. So what did the dissolving? So the solute is whatever is being dissolved by water or by any liquid. Okay? The solvent, which is usually water, okay, is what dissolved it. So think about making a pitcher of Kool-Aid. When you pour the powder into the water is the solvent, the powder is the solute. Okay, so that's how you can think of how these work. Now that solute is going to just scatter around until it's evenly spread out. And the movement of those particles of solute, the movement of the particles tends to be from an area of high concentration. That's near the solute. So when you pour that powder in, all that column of powder as it's sinking, that's going to be an area of high concentration to an area of low concentration. And that's going to be throughout the water. So when you first pour it in, all that powder is dropping down. That's a high concentration of powder. Lots of powder. That is a high concentration of solute. And then all out in the pitcher, where it's just plain water, that's going to be an area of low concentration because there's no powder over there yet. So hopefully that makes sense if you think about making something like Kool-Aid. Now, this is what that looks like. So you have a lot of powder over here. So these are your little particles of solute. Here's your high concentration. And these little particles are going to move this way because over here there's none of them. So this is your low concentration. So this is known as diffusion. And that definition is, diffusion is the movement of particles from an area of high concentration, so where there's a lot of them, to an area of low concentration, where there's not much. All right. Now, diffusion is always going to happen. It happens in water. It'll happen in air. You've all dealt with that. If someone sprays perfume and you're standing right beside them, well, you smell the perfume immediately. But if you're standing down the hall somewhere, maybe a couple of minutes later you go, "Who sprayed something?" All right. That's because it takes a little while for those perfume particles to move down the hallway. All right. So this happens with anything like that. Now, diffusion cannot occur without a concentration gradient. And a concentration gradient is a difference in the concentration of substance across a space. So that is when you have a lot of it in one spot and not any or not much of it somewhere else. And that would be like spraying perfume. So let's say somebody's sitting at the front corner of my room, pulled out some cologne and put it on. Well, everybody sitting right around them smells it immediately. But the person back there in that back corner, they're not going to smell it for a few minutes. Okay, that's your concentration gradient because you have a lot of it in the front corner and none of it in the back corner. All right, and since things diffuse from an area of high concentration to an area of low concentration, they are said to move with the gradient. All right. And if no other process interferes, so if there's not something there to stop it like a wall, all right, diffusion will occur until everything is evenly spread out. All right? And you can see this at home. If you take a pitcher of water and put it on your counter and let it get really still, and then put a drop of food coloring in it and don't stir it. Just don't touch it. Just a drop and leave it alone. All right, come back about an hour later and the whole pitcher will be colored the same color, even though you didn't stir it. Try it at home. You'll see diffusion happening. All right. Now, osmosis is the diffusion of water. And the reason why we have a different name there is because the diffusion of water into and out of cells is so common. It happens so often that we gave it its very own name, which is osmosis. So osmosis is the diffusion of water molecules through a selectively permeable membrane. That's going to be our cell membranes normally. Okay, from an area of higher water concentration to an area of lower water concentration. So what that means is that water is going to move from where there is more water to where there is less water. Just remember, water doesn't like a crowd. Wherever there is more water, water wants to leave and move to where there's less water. Okay? And there are three different types of solutions that you can talk about when you are doing osmosis. Okay? The first is called an isotonic solution. Okay? An isotonic solution is a solution in which the concentration of dissolved substances is the same inside the cell as it is outside the cell. So what we're talking about here is, let's say salt, because salt is a very common substance that's in cells. All right? And so you have the same amount of salt inside your cell as you have outside of your cell. Okay? Same amount, inside and outside. Now, if you have the same amount of salt in and out, that means you have the same amount of water in and out. And so, a cell placed in an isotonic solution is in dynamic equilibrium with the surrounding solution. Water's going to move in, water's going to move out, but nothing's actually going to change. It's just going to be a constant back and forth and back and forth. All right? So nothing will happen to the cell. Okay? A lot of cells like isotonic solutions. And this is just an example. If you look, for every salt, there's a water. For every salt, there's a water. For every salt, there's a water. Outside, inside, every salt, there's a water. Every salt, there's a water. So it's the same in and out. The arrows show how the water moves in and out equally. You can also have something called a hypotonic solution. A hypotonic solution is a solution in which the concentration of dissolved substances is lower outside of the cell than it is on the inside. So now you have more salt inside the cell than there is outside. Okay, more stuff in the cell. And so if the cell is placed in a hypotonic solution, osmosis will cause water to move through the membrane into the cell. So what you're looking at is, since there's more stuff in the cell, there's less water. That means there's more water outside. And water wants to leave. It wants to go in because there's less water in there. And so the water will go into the cell, and that will cause the cell to swell up. Hypotonic. All right? And as turgor pressure increases, we'll talk about turgor pressure in just a second. All right? So this is what's happening here. See how there's not much water in here? But there's a lot of water out here, and that's going to make that water go into the cell. And as you push water into a cell, it's like putting water into a water balloon. It swells up, just like you make in a water balloon. All right? And so water's going in and the cell is swelling up. Now, when that happens, the turgor pressure increases. The turgor pressure is the pressure that exists inside a cell. So think of it kind of like your tire pressure. Okay, when your tire doesn't have much air in it, it goes flat. Well, without a lot of water, the cell is kind of flat. Pump some air into your tire, it pumps up and its pressure increases. Same thing when you pump water into a cell. It pumps up and the pressure increases. That's the turgor pressure. Now, it's what gives non-woody plants their shape and support. So this is why if you don't give your plants water, they droop. All right, but once you put water in them, they perk back up. All right, it holds them up because it's pumping up the cells. All right, that's why they will. But animal cells can burst in a hypotonic solution. Think about a water balloon. How many of you have ever made a water balloon? Put the balloon on the faucet, turn the water on, and you wait too long to take it off. That balloon explodes because you put too much water in it. Cells, animal cells will do the same thing because they don't have a cell wall to help hold them together. No cell wall, they'll pop just like a balloon. All right, and then you have hypertonic solutions. A hypertonic solution is a solution in which the concentration of dissolved substances, so salt, is higher outside of the cell than it is inside. So there's more salt outside than there is inside. That means that there's more water on the inside. And since there's more water on the inside, if a cell is placed in a hypertonic solution, osmosis will cause the water to leave the cell. Remember, water doesn't like a crowd. More water on the inside, it's going to go out. All right? So this will cause the cell to shrivel up. All right? Animal cells literally dry up like a raisin, and plant cells wilt. All right? A loss of turgor pressure in a plant cell is called plasmolysis. So when you see your plants that used to be all nice and perky because you gave them enough water, they wilt. That's because their cells have undergone plasmolysis. They've dried out. And so this is what's happening in a hypertonic solution. A lot of water inside, see it? Very little water outside, lots of salt. And so the water is leaving the cell, and that's going to shrivel up the cell. All right, so when you look at how these solutions affect different cells, okay, up here we have animal cells, no cell walls. Down here we have plant cells. All right, and notice in a hypotonic solution, it kills animal cells. They blow up, and if it bursts, it's dead. But this is where plant cells are happy. They like to have lots of water inside. They like to be pumped up. So hypotonic kills animals. It makes plants happy. Okay. Isotonic is where animal cells are happy, but plant cells are starting to droop a little bit. Okay. So they're okay, but a little droopy. But animals are happy in a isotonic solution. And in a hypertonic solution, nobody's happy. Plant cells shrivel up, that kills them. Okay, animal cells shrivel up, that will kill them too. Nobody likes hypertonic. All right, hopefully if you have any questions, you'll ask me about them when you get a chance.